Alrighty guys, we're going to do some nomenclature review. So what you're going to need is a piece of notebook paper and your periodic table. Okay, so a couple things. The reason why I'm wanting to go over nomenclature is, for one, it's a really big topic on pre-comps. And also, I was grading some of your guys' tests, and a lot of you guys are struggling with this. So I'm going to make sure that you watch this video start to finish. Okay, you're going to want to watch it all the way through with the audio on, listen to everything I'm saying, and work out all the problems with me. Okay? Okay, so first thing, on your periodic table, if you don't already have these things written on your periodic table, you should. Write the charges at the top of the periodic table. Okay, +3, and then you can skip this one. And then you can go -3, -2, -1. If you don't have those charges written at the top of your periodic table, then let's write them right now, okay? Okay, because that tells you that all these guys are -1, and all those guys are -2, etc., etc., okay? Another thing that we all need to have on our periodic table is the triangle drawn. This is our triangle. That triangle, this triangle is the metals that are, they look like transition metals because they're in this transition metal block, but they have specific charges. So these guys are all +3, which, makes sense because there's a +3 here, right? But these guys are always +2. So if you want to write that somewhere, I don't know where, that those guys are +2. And then this one right here, which is silver, this one is +1, okay? So those ones you should have memorized or written on your periodic table as well. You should have your staircase drawn on your periodic table, okay? You should have your staircase drawn on your periodic table because that separates the metals from the non-metals. That way you know, okay, and if it helps you, write it down here. Metals are on this side, and then your non-metals are over here. Non-metals on this side. Sorry, that's really very ugly images. Okay, so your non-metals are on the right, your metals are on the left. And that's important because if you just have non-metals, then that's going to be a covalent compound. If you have a metal and a non-metal, that's going to be an ionic compound. And the rules are different, remember, for naming ionic and covalent compounds. Everything we're talking about today is in your notes. I want to say pages 10, 11, and 12, maybe, or 11, 12, and 13, maybe, 11, 12, and 13. So this is all review from way back in our bonding unit, but I keep giving you guys nomenclature questions on your tests and quizzes, and there's a large chunk of you who keep getting them wrong over and over and over again, and I think it's because you either never learned it in the first place, or you're forgetting, or you're rushing, or you're confused, so I'm going to try to help you with that today, okay? Okay, cool. So I think that's all I need to talk about right now. So let's get out a sheet of notebook paper. We're going to work through 20 problems, and you need to write everything down that I'm writing down. Okay, so you need to write down number 1, NH4Cl. Okay, so NH4Cl. Let me see if I can zoom in. Okay, so our first compound here, NH4. So first thing I notice in this compound is it is not binary, meaning it has 3 different elements in it. Because it has 3 different elements in it, I know that it has a polyatomic ion in it. So I have to look and see which one of these is my polyatomic ion. Well, this one looks kind of familiar from your polyatomic ion list, NH4. If you have your polyatomic ion list, it's on the back of page 12 of your notes if you want to flip to that. Look for the thing that says NH4. That's called ammonium. So we're going to say this is ammonium. And then what do I have left over? I have a chlorine left over. But instead of saying chlorine, I'm going to say chloride. Chloride, right? Because where's end in ide? It's not a polyatomic ion. Okay, so ammonium chloride. Oops, I got an extra C in there, I guess. Okay, so I had a formula. I translated it into words, into a name. All right? Let's look at this one. This is another one. I see more than 2 elements. And when I say more than 2 elements, I see more than 2 capital letters. I have a capital M, a capital N, and a capital O. That must mean there's 1, 2, 3 different elements here. So I need to look at this. So ammonium is the only polyatomic ion that's going to come first in a formula. So if it's not ammonium, then the polyatomic ion's always going to come second after a metal. So this one I have magnesium, and then I have NO3. So let's write magnesium. Now, magnesium is a metal, correct? How do I know that it's a metal? Well, if we look at our periodic table, magnesium is on the metal side. It's on the left side. Does it need a Roman numeral? Well, the only ones that need Roman numerals are the ones that are basically in this section. These guys need Roman numerals because we don't know their charges, right? Those are the ones that need Roman numerals because we don't know their charges. So magnesium, we do know its charge. Its charge is +2. So magnesium does not need a Roman numeral. Okay, so it's going to be magnesium, no Roman numeral, and then NO3 is called nitrate. You can find that on the back of page 12 of your notes. Nitrate. Okay. All right, the third one down says B2S. Okay, so let's look at this. I only have 2 elements, so there's no polyatomic ion. B2S. B is boron, which is a nonmetal. S is sulfur, which is also a nonmetal. They're both nonmetals. If they're both nonmetals, then it's a covalent compound, and that's when we use prefixes. And remember, prefixes, mono, di, tri, tetra, those things tell us how many of each element there are. So there's 2 borons, so it's going to be diboron. And then there's only 1 sulfur, so I'm going to say monosulfide. Remember, you have to end in "ide." If it's a polyatomic ion like this, you leave the ending the way it is. But if it's not a polyatomic ion, then you end it in "ide." Okay? Okay, moving right along. This one right here. This one clearly has more than 2 elements, right? This one definitely has more than 2 elements, so I know that there's a polyatomic ion in there somewhere. So my first element is sodium, so we can write sodium. Does sodium need a Roman numeral? Let's see. No, sodium does not need a Roman numeral because it's not a transition metal. So we're just going to write sodium, and then C2H3O2 is a polyatomic ion called acetate. Acetate. That's on the back of page 12 of your notes. Okay? Number 5. Again, you should be writing this down as we go. Number 5. I see more than 2 elements, so I know a polyatomic ion is in there somewhere, so that must be my polyatomic ion, the PO4. Okay, so I have nickel is my first element. Nickel. And then does nickel need, let's see, where's nickel? Nickel is right here. Nickel's right here. See that? Okay, nickel needs a Roman numeral. Why does nickel need a Roman numeral? It needs a Roman numeral because it is not, we don't know its charge. It's not in groups 1 or 2, and it's not in the triangle, so it needs a Roman numeral. So let's leave space for Roman numeral. We'll come back and figure that out in a second. And then PO4 is called phosphate. Phosphate. Now, if you look at your polyatomic ion list on the back of page 12 of your notes, phosphate has a -3 charge. Okay, phosphate has a -3 charge. If phosphate, I'm going to come over here for a second. In this compound, we have 1 nickel, whose charge we don't know, and we have 1 phosphate, 1 PO4, whose charge we do know is a -3. If phosphate was a -3 and there's only 1 nickel, then nickel must be a +3. So it's got to be nickel 3 phosphate. Okay? Okay. Let's look over here at this one. Cr2O3. Okay, so Cr is chromium. Chromium. Does chromium need a Roman numeral? Yes, it does, because it's in the transition metal area. So it's going to need a Roman numeral. Okay, so we'll figure what that is in a second. Then we have just an oxygen. So there's no polyatomic ion here. There's only 2 different elements. So it's just going to be oxide. Now let's figure out what that Roman numeral was. Okay, well, we have, I'm going to zoom out again over here. We have 2 chromiums whose charge we don't know, and then you have 3 oxygens. We know that each oxygen has a -2 charge. How do I know that? Because right there, it tells you right here. Okay, so if this is a total of -6, this has to be a total of +6, which means that each individual chromium has to have a +3. So that must be chromium 3 oxide. Okay, there will be a problem like that on pre-comps. There is every year, where they try to get you to figure out what that Roman numeral is. Okay, this guy here, I've got Si7. Okay, so sulfur and iodine, if we look at our periodic table, sulfur is here, iodine's here. That means they're both nonmetals. If they're both nonmetals, it's covalent, which means that we have to use prefixes. So it's going to be sulfur, and then, because there's only one sulfur, and remember, we don't use mono for the first element, so it's just sulfur. It's not monosulfur, just sulfur. We only use mono if it's the second element. So it's sulfur, and then heptaiodide. And it kind of depends on what website or textbook you're looking at. Sometimes they'll chop off this A here. Just kind of depends. If you're looking at like British textbook or an American one or whatever. Okay, hepta is 7. Okay, this one also only has 2 elements, so there's no polyatomic ions. It has carbon and fluorine, which are also both nonmetals, so we have to use prefixes as well. So it's going to be carbon. And then what is 4? What is 4? 4 is tetra. So it's going to be tetrafluoride. Tetrafluoride. Okay, this guy here. This is cadmium. And then this clearly has a polyatomic ion in it right here, huh? So cadmium, first, does cadmium need a Roman numeral? Okay, at first glance, you might think, if you hadn't drawn your triangle, you might think, hey, cadmium might need a Roman numeral. But since you drew your triangle, you know, wait, cadmium doesn't need a Roman numeral, because we know that cadmium has a +2 charge, always. So if we always know its charge is +2, do we need a Roman numeral? No, we don't. So cadmium, do not use a Roman numeral for it. OH is called hydroxide. That's it. Now we're done. Okay. Alright. Next one is SnO2. So Sn is tin. Let's look at tin. Tin is over here. Tin, I feel like I should make this stand out a little bit more. Tin is right here. Hopefully I'll change colors. So tin, it is a metal, okay? But it's not in our traditional area here of transition metals, but it does need a Roman numeral. People always forget about tin and lead. They do need Roman numerals, even though they don't really look like transition metals, okay? Tin and lead do need Roman numerals because we don't know their charges. Okay, they're not in the triangle, they're not in groups 1 or 2, so they do need Roman numerals. So it's going to be tin, Roman numeral something, oxide. Let's figure out what that Roman numeral is going to be. Problems like this are on pre-comps every year, so you need to know how to do this. Okay, so if you need to figure out that Roman numeral for the tin, so we know we have 1 tin, we have 2 oxygens in this situation here. So you know that each oxygen is -2, and you know you have 1 tin, and you got to figure out its charge. Well, again, if oxygen is -2 and there's 2 of them, that's a total of -4, which makes tin +4. So it's tin 4 oxide. And you have to do a Roman numeral 4. You can't write the number 4. It has to be Roman numeral, which is IV. If you just look at this, you wouldn't necessarily know right off the bat, that's tin 4 oxide, because there's not a 4 anywhere in there. The way you figure out that there's a 4 there is by kind of writing it out. You say, okay, I got 2 oxygens and 1 tin. Each oxygen's a -2, therefore the tin has to be a +4. So you got to use some reasoning brain skills to do that, okay? Okay, cool. I'm going to tell you guys right now, I'm going to pause for a second and tell you that I'm going to give you a secret word, because the secret word is going to be on your assignment to help me know that you have been listening to this lecture. The secret word is turtles. Okay? That's the secret word, turtles. Okay, cool. We'll see how many of you get that right. All right. So this one is lead. So now I'm giving you names. I want you to tell me formulas. Lead 4-phosphide. Okay, so lead 4-phosphide. This is an ionic compound, which means we have to crisscross our charges. How do I know this is an ionic compound? I have to crisscross my charges? I don't see any prefixes here. And it has a metal and a non-metal. Those things tell me this is ionic. I need to crisscross charges. So lead is Pb. Its charge is 4. It tells me right there. How do I know it's positive 4? Because metal's always positive. Okay? And then phosphide is just phosphorus. It's just ide, so it's just the element phosphorus. Phosphorus has a charge of -3 on the periodic table. Okay, so phosphorus is -3. So when I crisscross, it's just going to be Pb3, P4. Okay, so you crisscross those charges. And when you swap and drop or crisscross the charges, you don't put plus or minuses when they're subscripts, okay? Just put the number. I'm going to zoom in more. And you should be writing all this. Number 12, lithium nitrate. Okay, so lithium is Li. It has a charge of +1 on the periodic table. Nitride is just nitrogen, which has a charge of -3 on the periodic table. Crisscross them to get Li3N. Okay. All right. Lithium nitrate. Do you see the difference? This one was lithium nitride. This one's lithium nitrate. So again, it has lithium, which has a +1. Nitrate is a polyatomic ion. If it ends in 8, it's a polyatomic ion. And it's on the back of page 12 of your notes. That's a +1, that's a -1, so it's just going to be LiNO3. So I want to point at that. I did that to point out, look, lithium nitride and lithium nitrate are two different things, even though they sound really similar. Okay, the next one here is ammonium cyanide. Ammonium is a polyatomic ion. It's NH4+. Cyanide is another polyatomic ion. Cyanide and hydroxide are our only polyatomic ions that end in ide. Okay, one's a +1, one's a -1, so it's just NH4C. Oops, that should be a C. Wow, sorry about that, guys. It's all gone. Sorry. NH4CN. That's ammonium cyanide. Okay, silver bicarbonate. Silver is Ag. What's the charge on silver? Well, it's right there in our triangle. Silver is +1, always, all the time. Okay? So, silver has a +1 charge. Bicarbonate. Okay, people get confused about bicarbonate because bi sounds like 2, kind of like di. Bicarbonate is a polyatomic ion on the polyatomic ion list, and it looks like this. Okay? It is not 2 carbons. Okay, that would be dicarbonide or something. Okay, bicarbonate looks like this. So silver bicarbonate will be AgHCO3. Okay. All right, zinc biphosphate, another one. Biphosphate, so zinc. Zinc is one of those in our triangle here as well. Zinc is right here. Zinc has a charge of +2 all the time. So zinc is going to be +2. Biphosphate is HPO4 with a -2. So it's a +2 and a -2, so it's ZnHPO4. Okay. Okay, cool. This one, iodine pentafluoride. So iodine penta. I see a Roman numeral here, penta. Penta means 5. So that means I'm not crisscrossing charges because this is covalent. So I just do what the prefixes tell me to do. It says iodine pentafluoride, so that's F with a 5. That's it. Okay, copper 2 carbonate. Copper is Cu. It's telling me the charge is +2, so I don't even have to look it up. And carbonate is a polyatomic ion, CO3 with a -2 charge. So +2 and -2 are going to cancel, and it's going to be CuCO3. Okay. All right, iron 4 sulfide. So iron is Fe. Its charge is +4. Sulfide is just sulfur. What's sulfur's charge? Let's look it up. Sulfur has a charge of -2. So -2, that's a 2. Okay, but remember, if you can reduce the subscripts in ionic compounds, you should. So you'd only need 2 sulfurs for every 1 iron, right? So it would really be FeS2 once it was reduced. Okay, so for ionic, reduce the subscripts. For covalent, don't. Okay, for this one, dicarbon tetrasulfide. Okay, I see prefixes. That must mean it's covalent. It's full of nonmetals. So we just do what the prefixes tell us to do. So dicarbon means 2 carbons. Tetrasulfide means 4 sulfurs. Okay, there we go. Okay, all right, that's all. That's all I have for you guys. Hopefully you wrote this all down. You remember the secret word. And we're going to go ahead and do an assignment. Also, I'm posting the key to your test. You need to go over it. You need to learn from your mistakes on the test because there's a remediation quiz coming up.